Welcome to the 21st part of this tutorial series. I'm sorry I haven't made a video in so long. I had to finish my quarter at school, but I promise that I'll try to make at least one video a day from now on. Last video we created our player input system. Well, at least the basis for it. And this video we shall begin with implementing the first-person camera. Now, in this implementation, we will use some matrix and vector math, which I'll try to explain the best I can. So let's actually begin by going to our vector3 class. So go to vector3.h, So in vector3.h, we will create is the normalize vector3 function. Now, what is normalizing? When we normalize a vector, that means we give the vector a length of 1. So it's difficult to explain, but let's first create the actual function. So create type vector3 normalize vector3, and we only need one vector, vector3 vector. Just call it vector. Okay, then go to the .cpp file so we can implement it. And now also include math. So simply include the math, what's it called, the math.h library. So the first thing we need to do is calculate the length of the vector. Now, to do that, we can apply the Pythagorean Theorem. So I think all of you should know that one. The only difference is that we will apply it in 3 dimensions. So I'll show you. So begin by typing GL float. And have simply do float for now, doesn't matter. Float, and then do sqrt, so the square root of a double. And actually now let's do it proper. So go to vector3. Oh, never mind. So, oh damn it! Wow, sorry guys. GL double. So normally the Pythagorean theorem is only done with 2 dimensions, but you can easily extend it to 3 dimensions. So simply do the following: vector dot x multiplied by vector dot x, and then we simply take this and we do plus and plus, and we change the last one to z. So vector z multiplied by vector z, and the second should be vector y multiplied by vector y, and we add them up, and then we take the square root of them, and then we get the length. I forgot to name the variable. Now that we have the length, we can apply this. So create a new vector and call this the unit vector. And this will be the vector with a length of 1. And to do that, it's quite simple. When we have the actual length, vector3, all you have to do is do unit vector equals vector dot x divided by length. And we do this for every component, unit vector dot x, of course. And we do this for every component of the vector. And simply change everything to the second row to y, and then z. And then we simply return the unit vector. So again, what we should have done is we first calculate the length of the vector with the Pythagorean theorem, and then we divide every component of the vector by by the length. And this way, if we would again, if we would calculate the length of this unit vector, the length would be 1. And the reason we want 1 is because we can very easily manipulate that 1 into a different value. And I'll show you that in a second. So first now, go to your player input system.h and create a new public method and call it input. So void input. I'm sorry, update, not input. Update and update, yes. And also let's create, at least for now, include our entity. So include the entity.h header, create a new entity and call this underscore current player. And also create a setter and the getter. No, only setter for now. And call it entity. No, sorry, void set current player entity new player. Okay, then let's implement all of this. So go to player input system.cpp and at the top of the file let's implement our current player system, player input system. And simply do current player equals new player. Oh, what's wrong here? Forgot to make it a pointer, so also let's do this in the header file. Small mistake, I'm sorry. Then it should be okay now, yes. Okay, then our input method, let's do it underneath our key callback method. So simply do void player input system update. Okay, and for now let's create an if statement. If current player is not null, obviously, and also and if our GLF get input mode of our current window, we actually have a window now, we'll make one, is GLF disabled, sorry, GLF cursor disabled, because we only want to do this when the cursor is disabled, of course. No. I'm sorry. This should be GLF cursor and it should be equal to GLF cursor disabled. Yes, like this. And okay, and for now nothing. Then let's create our window. In our constructor, simply do underscore window and GLF get what? Get current context, of course. And then in our play input system.h, let's actually create the window. And it's a private variable, of course, so glfw window pointer to underscore window glfw. Everything should be fine now, I hope. And it's fine, and yes, it's fine. Okay, now first off, let's go to gamemanager.cpp and go to run game loop. and in this small while loop, underneath update underneath movement system update, simply call underscore player system player input system update like this. Now go to your scene.cpp, and first of all let's remove this. We can leave all of that. Leave that, but in our camera let's remove the velocity, and let's actually set our I vector to something. So first of all, set the position of the camera to 0, and for our so our I vector is the vector we need to normalize. It does not matter what the actual values are. The only anything that varies is in what direction it's pointing, and for that the actual length of the vector does not matter to us. So create here normalize vector 3. So normalize vector 3, and you can do like make vector 3 and simply do something like let's look directly at our cube, which is simply at looks like 1 something. Let's just look in the minus direction. So do minus. So do 0 for the x and 0 for the y, and minus 1 for the z, which actually is, what will this give us? We don't actually see anything. Maybe I should do like plus. Nope, still nothing. Where is the cube actually? Let's put it at at minus 1, and let's look at minus 1, and what do we see? No cube, damn it. And let's remove the rotation and the scale also from the cube. Just get rid of all of this. Okay, and if you run it now, still nothing. Maybe do like 5, or should be plus, I forget that. No, get this. And yes, okay, finally. So now, so make this like 5 and this like 1. Obviously this vector is already normalized, but this value at the moment is just an initial input and nothing more. And you'll see why, in a minute there. So now go to your player input system.cpp, and now, so let's create the following glf in the update method. So here, if, so obviously this will only be called when there is a current player and the mouse cursor is disabled. So if glf get key of the window, and say for forward movement we want the W key, so simply pick glf underscore key W. We want to do the following. First of all, before we do anything, go to player input system.h and create a new vector. I'll just move this for a minute here. Create a new vector and call it I vector. So vector 3 underscore I vector. And in player input system.cpp, our I vector will equal I vector. So in the setter for the current player, our I vector will equal new player dot get I vector, like that. And so this vector is normalized, and to be sure, let's actually normalize it again. So normalized vector 3. If we normalize a vector that is already normalized, we just get the same vector, by the way. So it does not matter. Now, say we want to move forward. In that case, we simply have to take our vector, so our I vector, and add that vector to our current position. So when we press the V key, what we will do is we will do current player set set position and add vector current player dot get position, and we will do that by the I vector, and let's actually do it like this, do by the I vector, like that. Okay, now we're not done. Our direction vector, so our I vector in so in our render system, we use this this function right here to set our model view matrix, and here is the position of the camera, and the second two were the direction in which the camera is actually looking. So these three should actually always be the position plus plus the actual I vector, so that way our camera is always looking in front of the in front of the actual position, if that makes sense to you. So what we should do is, underneath we should do current player set I vector, and we will in the future modify this code and move the stuff to a more appropriate place, but for now do add vector current player dot position, dot get position, and the I vector. So that way our camera is always basically looking forward, so before the actual player. Now go to your scene.cpp, and for now let's make our camera the player. So let's actually include our player input system. So include player input system.h player input system equals new, equals add player input system get player input system, and then simply do player input system set set current player to camera. Okay, now if we run this and press the W key, we fly forward. That's because we're actually adding quite a lot. Now, here is one of the reasons we want to normalize our vector. Because this vector is now has a length of 1, we can quite easily just multiply it with a value, and that way we will get a more appropriate speed. To do that, simply go to vector3.h and create a new function here called vector3 scalar multiply vector 3. So our vector 2 multiply, so vector 3, vector 2 multiply. Yes, I like navy stuff. And a GL float, and this will be our scalar value. So a scalar multiplication is simply when you multiply a matrix or a vector with a single value. And then to implement this, simply go to vector3.cpp, and this has a very simple implementation. Simply create a new vector. So vector3, new vector, and new vector dot x equals vector to multiply dot x multiplied by scalar value, and that's it. A very simple implementation. And don't forget to change these values to y, and to z. And let's also then return the actual vector. So return new vector. And now we're here anyway. Let's create one more. Function. Underneath the add vector function, let's create the subtract function. So subtract vector 3, like that. No, I think it's actually with like that. Subtract, yes, subtract vector 3. So same like here actually. Yeah, so just copy this implementation of the add function like that, and instead of adding we will do minus. It's that simple. Then just copy this, go to vector3.h and paste it there. Very simple. Then back in our player input system.cpp, let's do the following. Do scalar. So instead of just doing I vector, let's do scalar multiply vector 3 or I vector with a value, let's say 0.07. F should be a nice value there. And let's create now a new if. Now value will be moved backwards, and that will be the ASCII. And instead of adding, we will now subtract vector 3. And now if we run this, should be nice and smooth. Yeah, we can move forward and we can move backwards. Now for side view movements, let's do that in the following video, because this has been already a long one. So yeah, I'll post. I'll give you a link to the code in the description, and I hope you like this. Bye.